I wanted to get a mobile transceiver, so late last year I bought a VGC VR-N76, one of these things. My decision was made by a couple of recommendations, but also because I was quite price limited. I think I was swaying towards the Yaesu because I do have a lot of Yaesu radios. But it's a very fun radio. I really enjoyed using it. It's very rugged. It's pretty much waterproof. It seems to be very indestructible. I've dropped this. I've been knocked out my hands by my wonderful large dog. But yeah, it's a great fun little radio. I didn't really want to make this video about the radio, but I did want to talk instead about the stock antennas that came with it. They're rubbish. I know they're rubbish because I can plug it into my externally mounted antenna, my Slim Jim, and the radio performs really well. It would talk to all the repeaters, talk all over the county I'm in. But when I plug it into the stock antennas, it really doesn't pick very up, and it's even worse when I start having the radio actually in useful situations, like actually in my pocket or on me. These radios are very poor on 2 meters. They work a bit better on 70 centimeters, which you kind of expect. I mean, VHF is very forgiving. 2 meters is very forgiving. You can plug it into a piece of wet string and it will work, but they just didn't work very well. And I shouldn't have been surprised, and I wasn't surprised because it's a cheap radio and it's got a cheap antenna. But I felt that perhaps it was worse than it should have been. The great thing is, I actually have 2 of these because I have another radio ham in the house, and so I actually have 2 of the antennas. So I did what any of us would do. I'd grab my VNA and plug it in, and it was as I expected. The antenna isn't a very good match on 2 meters. And surprisingly, it actually wasn't a very good match on 70 centimeters either. Now, we'll get into the figures in a moment, and they are definitely better at 2 meters than anything else, like 4 meters or 1 meter. But are they as good as you would suspect they should be? And I told my dad about this, and he was like, "Oh, did you do the experiment right? I bet you just had the antenna lying on your desk." Like, no, okay, I did, yeah. Well, you're going to have to do it again, but this time you have to do it in free space. I also realised I was going to have to upgrade my antennas. These little stock antennas, if you imagine 2 meters, whilst it's very forgiving and you can pretty much use 2 meters on a bit of wet string, it's not very long, and the length does matter, even as you imagine a quarter wave of 2 meters should be about 50 centimeters, and this very much is not 50 centimeters. So I bought an RHD 771, and I also bought this looks more like the 50 centimeter quarter wave stub antenna you should expect, but I also bought a HYS 771Q as well. Interesting, they're both called 771. I wonder if that's a length actually, and they're both listed as SMA 2 meters. When you're trying to find antennas online, it's really difficult, even if you're on not just Amazon but on like some of the amateur radio shops in the UK at least. The shopping is very difficult. They're all advertised with a picture, you get a brief description, you get a price, you might be told about the connection, so it's an SMA, but actually there's 4 SMA connectors. Some of them don't even show you a good picture of the SMA, so you don't know which end of the SMA it's on. Is it a male, is it female, is it the screw end or the thread end? So yeah, it doesn't really tell you, but there's no Smith chart, there's no propagation estimate, there's no VSD bar meeting, anything. You basically have a serial code, and often these devices they're made very cheaply abroad, and you can't find the original manufacturer, and you can't go find their website, and even if you can, they might not have this documentation available. So these are clones, so someone is just churning these things out in the factory, and you don't know what they are, right? And so I bought 2 of these antennas. I bought these both antennas. Both of them are £10 or less, so they're nice and cheap. And I suspect that's the sort of price point of the antenna that came with the stock. If a radio is £80, you're not getting a £100 antenna in that box. So yeah, bought them, waited for them to arrive, and immediately both these antennas outperformed. You just plug them in, and immediately they work so much better in the real life. But first of all, let's look at what tests we're going to actually run on these. So you've got the practical test, that very qualitative test of going out there and using it. In terms of a quantitative test, we're going to use a vector network analyzer, or VNA. But what is a VNA? A VNA is a precision instrument that you use to measure the performance of RF or audio components, anything you can put a signal in, not just antennas but filters or cables. It basically works by you generate a signal to a particular standard or quality level, and then you measure the signal coming back to say what is the reactance or the reflection of the signal. Amateur radio people usually care about the pure VSWR, or basically the voltage standing wave, which is bad for two things. One, it means the power is going back into the output stage of the radio. It's going back into heat and could damage the radio. But it also means your antenna isn't being efficient. You're putting some watts into a thing and they're not going into the air. The other thing it does, a VNA, is it looks at the phase difference of the return signal to the input. And this is the vector part of VNA. Any reactance on the machine will show up as a phase difference. Inductors and capacitances in the device will shift the phase in and out a little bit. And that in turn leads to a mismatch in the antenna. But because reactive components, coils and capacitors, they have a different effect at different frequencies. Basically, your VNA, you'll program to do a sweep of the frequencies that you're interested on to give you an idea of how the device performs. By measuring and drawing those outputs, you can actually have an idea of how to change your antenna. So if you're developing an antenna, this is very useful. The output of the VNA is usually in the form of a Smith chart, and a Smith chart is this big circular logarithmic chart. And we want to be to the point nearest in the middle as possible. The middle is a perfect antenna. The far left-hand side is a short circuit. It just goes straight round, there's no resistance. And the far right-hand side is a fully open circuit, a broken. So this line across the middle is effectively a resistance measure going from 0 to infinity, hence the logarithmic nature of this. The up and down components of this are the reactiveness, i.e. the capacitance and the inductance of the device. What we're interested in is how close to the middle can we get. So when we're comparing two different antennas, we can actually compare how close they are for a particular frequency. And that tells us roughly how good the antenna is, assuming that the power going into the antenna that isn't coming back is actually going to the air. So obviously free space, as requested by my father, is not something I just have lying around. I barely have space that is free, let alone actual free space. Free space is like a perfect mass, like a perfect circular thing. It is a medium which is pure, has no effect, there's no movement of electrons in that. It is a perfect transmission medium. And it doesn't exist in the universe, because the universe, even in the depth of space, has a molecule every kilometre or something crazy like that. So free space is just this theoretical perfectness. I've decided to use this area of air just behind my desk here to do it. The first thing we're going to do is calibrate the VNA. So because we're putting a little bit of an extension cable on to fit into my rig, which is a camera stand and a bit of cardboard, I have to calibrate it. So I'm calibrating it at the end of the wire, so the feeder wire has no effect on the measurements we're making. With that now done, we can now cut to the output and show you the output for a perfect antenna. And paradoxically, this is actually the worst antenna, but electrically it looks like a perfect antenna. It is actually the dummy load, it's the calibration dummy load. You see here there's very little on the actual antenna, it's effectively a resistor. The sweep you see here shows it's actually across 900 megahertz. It's going from 500 kilohertz all the way up to 900 megahertz, and shows the VSWR is practically 1. It's a little bit higher. The distance from this center point, you want it to be as close to the center point as possible. And you can see the worst thing is 900 megahertz, but it is effectively a perfect antenna. So this is to bear this in mind. The reason it's the worst antenna is because that energy is going into the resistor. All the energy is actually going into heat rather than into radio waves. But the test tool is measuring just that. How much energy are we putting into the antenna versus how much energy we come back. So this is now calibrated. The tool is calibrated. And this is what we'd hope to see from an antenna. But hopefully that it's not going to heat, going to radio. There is no real good test for knowing whether it's going to radio or heat, apart from then measuring with another antenna how much radiation you get off it, and therefore doing some kind of calculation estimating what your efficiency is. But as a general rule, if you've done the maths right, you can guess the energy is going to radio rather than into heat. In this case, it's 100% going into heat, or 99.9% going into heat. Also, we should take this opportunity, as my dog has just moved, to show how these actually can affect but I'll now plug in the first antenna under test
and we'll start taking some measurements. So this is over the 900 megahertz. As you can see, there's actually got a couple of dips here which are quite good. Over the entire bandwidth, the first dip happens here, which is at 144. It's a bit hard to see, but there is actually a dip at 144, which is fantastic, suggesting it is actually a 2 meter antenna. The second dip over here happens at around 208.60, which is a harmonic, I think, of this dip over here, the 549. These aren't the 70 centimeters. The 70 centimeters for 400s, 770 out here. And you see, it's a big spiral. When you have so many points so distributed out, you get a very big spiral. What we'll do now is just change this now to being, because I'm only cared about the 2 meters, so I'm going to change it for 144 megahertz to 147 megahertz. So it's still 2 megahertz scan, which is quite, it depends how you look at it. 2 megahertz is quite a wide scan when you're in the 144. It's not very high when you're in, you know, the gigahertz range, as a percentage of your total bandwidth sort of thing. But we do a scan there, and you can see now you get a much more consistent line, about 1 point, what's reading here on the screen, 1.9, nearly 2 SWR here. And so it's the distance to the middle. Where we're working 145.8, 144.8 sort of region, very, very similar. What's interesting here, this is dog's coming back, and we'll demonstrate the experiment. So I run the scan again. It's not really changing very much. There's a little bit of fluctuation. If I bring my hand real close to it, not touching, just real close to it, and run it, you'll notice that it begins to be affected much more. And if I bring my hand really close to it, that SWR goes all the way up. And it's really, and if I actually touch the antenna, now this isn't actually conductive, but touch it, it sort of falls all the way out here, all the way up to about 5.5. Bearing in mind this is a mobile handhold antenna, it's designed to be on the top of the rig, and therefore you're going to be holding it close to your face, you're going to be holding it on your body, it's going to be attached to your belt. These are what the antennas are supposed to be used for. So a free space test and saying, oh, but in free space it's good, it's not practically very useful. And so we'll be repeating that sort of test in a moment on the other two antennas. So this is the first stock antenna. As you can say, it has an inductance more than the capacitance to bring it down to about 1.1%, 1.8. This is a very acceptable antenna usage to 1.7. It becomes less acceptable when it's all the way out here. When it starts going out here to 2 and beyond. Here it's going up to where it's 3-ish. It becomes less acceptable. Same test again. This is the yellow antenna this time. As you can see here, it has the same level of inductance, but it's different. It's actually worse. You can see straight away on the SWR at the top right with the mouse cursor that the SWR starts here at 2. It's not even below 1. It starts 2. This is the free space test. I'll just check again. My hand's nowhere near it. Yes, it's starting all the way up at 2.2. Now what's interesting is that's my antenna. This purple one with the purple band on is my daughter's. And so my antenna was worse, and I was the one observing these antennas be bad. Straight away it's worse. It also moves up, and it moves up towards 2.5 to so on. Again, marking inductance, it's the distance. This is really the measure of how far away we are from that center point. I just thought that was really, like, I was quite shocked at how bad this antenna was. But what I'm more surprised by is how different the two antennas are. Again, if I repeat the experiment, I'm putting my hand near the antenna. You see it begins to move away. We're now up to 2.6, heading up towards 3 easily. If I actually touch the antenna, I'll just lightly touch that. Again, it's not conductive. You're all the way over 5 now. That inductance, it absolutely shoots to the roof on this antenna. So this particular antenna, when held against my body or sort of thing, the VSWR on that is all the way up at 5.5. Absolutely astounding level of a difference between these two antennas. They look identical. There's no reason to think they've been treated any different. They came from the same supplier. I put the order for both at the same time. There's no batch numbers on them, but they aren't the same. They are very, very different antennas. I did notice that when I changed when I recalibrated, I was getting more consistent results between the two antennas, but they're out of alignment. One of my friends asked what the spec of these antennas are, and the answer is I have no idea. So what is the tolerance? What do you expect from the tolerances of your antennas? Don't know. But yeah, that's the 2 stock antennas. So we'll move on to the other 2 now. This is the first 2 RHD771s. I bought 2 of these because I wanted to upgrade both radios. I had it on quite good authority that they are good antennas for 2 meters. So I plugged them in. This is one I haven't actually used on the radio. I've been using a different one on the radio. And it comes back for the 2 meter window as an SWR, surprisingly, of about 2.3. So throughout this distance, it's very, very tight. And this is something you want to see, is that, yeah, you've got consistency in the band. When you have a much wider band, you will have some, or if you're building a very niche antenna, you're only going to work, let's say, you're only going to work Whisper on 40 meters. You might want a very, very perfect match on that one tiny bandwidth, 25 kilohertz. But because we're all over the 2 meter bands, we're doing 144 work, we've got repeater work in 145, APRS work, I think is 144.8. You want to have a very consistent over the band. So again, if we sort of bring our hand near it on this time, though, we begin to notice that the effect of being near it is not so pronounced. So here it's actually getting slightly better as my hand gets near it, and then as I actually touch it here, it's 2.6. So this antenna is maybe not so great in free space or in its theoretical, but it's certainly much better as a handhold antenna, and that's what I'm observing when I'm using this out in the field. I'm getting contacts a lot further away, and I'm getting the repeater much more consistently, even if my body is beginning to be involved in that equation. So this is the RHD771 number 1, and I'll now go plug in number 2 so we can compare that as well. RHD771 aero number 2, very similar to the first one. You're seeing a 2.5 across the band up here. Again, distance here is very great. If I bring my hand near it, start getting really close to it and hit sweep, then it doesn't really move. Like, I can put my hand. It's very, very consistent in its usage. So yeah, these antennas are proven to be very good. I'll look at the price of them on Amazon. RHD 771. They're £10. Right. So as an upgrade for your system, you're looking at £10. Yeah. So having a quick look at Amazon for this, £10.92. If you want it next day, it's a little bit more expensive, £17. But if you're willing to wait a little bit, which I did. Now, what I actually like about this as well, this particular vendor here, is they actually show you what the plug is, and you'll be surprised the number of people who just say, "Oh, it's a 144 megahertz with an SMA connector," because there actually are 4 different types of end you can have, and obviously they're in pairs. So you have this one, which is the screw thread on the outside, but no pin in the middle, the female in the middle. There's the screw thread with a pin in the middle, and then there's the screw receiving the screw threads on the inside sort of cup onto that with a pin in the middle and without. So you actually have all of those. So for example, it might be hard to see in the camera, but this is a end without a pin in the middle, which is the same as what you see on this picture here. And then this is one with the same screw thread, but actually with a pin in the middle. It's very hard to focus on that, I know, but they do exist. So yeah, we'll now move on to the other antenna that I happen to have bought. So this antenna here, I bought, it was £8.99, so it's even cheaper. And what I liked about it was it's like a slap band. So it's quite a thick bit of metal, and antennas generally, the bigger physically across they are, is better. It means there's more of the electric field which is manipulating them. Obviously the length of them, the dimensions that way matter a lot as well. But wide. So this is a nice fat antenna. It's very thin this way with fat, and it's basically a slap band. For those, I don't know if they call that in other countries. In the UK, become slap bands, and generally you get given them as a kid, and you slap it on your wrist and it goes round. And usually they're like highly reflective. I wish this wasn't camouflage. I don't like camouflage stuff that much, but it is a camouflage tail. I will say that this is something I was very interested in because it folds up nicely. So when you want to, it will roll round in a tight ball. It means the entire radio, the entire package will go nicely, neatly into your pocket or your bag or whatever. I will say that when you're unrolling it, you have to make sure that the end is clicked. and if the end isn't clicked, it will just keep on going back. So once you've got the end clicked, it's nice. Okay, so this is it on the test rig. As you see, the SDR of this is actually pretty good in free-ish space, I should start calling it. It's got VSR 2 at the height over here, and it moves down to be an SDR 1.7. So in that free space, and as my hand gets near it, the SDR, let me run the sweep again. So hand nearish to it, it gets a 2.2, 2.3, 1.9, just under 1. As my hand gets really close and is actually touching it, that SDR again doesn't really move up. So again, it's great for mobile. My experience of this one, this one came in the mail first, so I went out, went for a walk with my daughter. My daughter had the purple antenna on, and I had that one, and I was getting more APRS contacts significantly. Like not just the power levels were higher, but I actually was hearing things that just were not even appearing on these sport antennas. So this one's fantastic. I do also know you guys are going to ask what happens when it's rolled up, because actually, let's say it rolls up, you don't notice, you hit transmit, or it just rolls up and you've got the APRS auto on. So we roll it up, so it's now a nice little coil. Obviously, coils and antennas match nicely. At this point, the SWR here, as expected, it changes, but the SWR isn't too high. So if it does roll up and your radio transmits, it's on auto transmit, you're not going to do a lot of damage, because it actually is still surprisingly good. It is on the capacitive side, which you'd expect. Now you've got something which is flat. It's not really a coil like you'd expect there to be like an induction coil, but it's more like a capacitor. You've rolled a tube up with an insulator in between, so it is actually more like a capacitor at this point. But it also acts has a bit of capacitance when it's out straight. So take what you will. I think this antenna is really good. The only downside is that if you are if you have it on you, it can sometimes just decide to roll itself up. But it has this practicality effect of that if you are using your radio on walks, but you don't want it out of the time, you don't have this giant long antenna lying around. So I know my wife is particularly happy with these giant antenna in the car, because I just sort of put it in the cup holder and there's this antenna sort of poking her in the face. Whereas this one I could roll it up because I'm not using it. Has that great feature. So really, really impressed with both of these two antennas. And I say the scores speak for themselves. Over the stock antennas, I don't have a second of these to test for quality. What I say is that on the RHD 771s, they seem consistent. The two I bought seem to be very, very consistent, whereas these stock antennas that come with the radios, wildly different results. And in practicality, when you hold them near to you, you begin to get very low results. So yeah, I hope you guys found this useful and interesting, and I hope I don't get complaints about my free space experiment, my test rig, and how I'm keeping myself away from it. I hope that has put an end to this, that I think these are rubbish. Did I get a bad batch? Do I have broken ones? Are they something which you just throw out for £10 to replace that particular unit? Is something better, more specific to me? We'll see. Like to hear your comments, like to hear your feedback. That's it for me today. Thank you very much for listening. If you want to see more of this stuff, please hit like, hit subscribe, and leave me a comment about what kind of stuff you'd like to see. I always like to hear back from you guys. I know some of you guys hit me up in Discord, and that's always appreciated. Thank you very much.